Welcome to Qt Widgets and more. In this episode, I'll look at code coverage using the tool gcov. So before we get started, I'd like to say thank you to a few of my coworkers who helped me with this episode. First of all, Zeno Enderman, who wrote an education report, mind you, 2 years ago, but nevertheless took me a bit of time to process it, and that is the starting point for much of what we'll see today. Then, as a follow-up to his education report, Paul Lemire gave his input on how he was using gcov in his project. And finally, in actual creating the material for this project, I had a bit of problems with cmake, and David Four, who you know from this channel, helped me out. So thank you to all three of you. So the background for this episode here is that I was looking for a way to identify if I had any dead code in my code base. And one of the suggestions out there is to run gcov, and then you can see the code coverage. And obviously I'm not unit testing all of my code, so there would be places that wasn't unit tested. But on the other hand, I have a self-check mode where I load all the 107 dashlet that my application is made out of. So I load all of these in the self-test mode, and I had an idea that at least that would trigger a larger part of the code base. So I thought, hey, let me try and set up gcov for that. And what I'm going to show you now is the steps that I took for this. And let me admit upfront that I had quite a few problems with it, and not all of it worked out. But in the end, at least I got somewhere that I thought would be useful for you. So let me walk you through each of the steps that I did to get this working, and I'll tell you a bit about the dead ends that I met when I started out. So first of all, I'm creating a shadow build of my setup. So I'm creating this directory, and I'm cding into it. And what I then ran was a cmake command. And let's just decipher what the cmake command does. So starting from the end, .qtopia, that is the source directory that I specify there. And from the end, -g ninja, that means that I'm just building with a ninja build. There is a link right here to an episode where I analyze the speed up that you get from using ninja over make. I also specified this cmake toolchain file, and that is a way of specifying some additional parameters to your build flags. We'll look at that file in just a second. But why did I need to do that? Well, as I said, I need to specify minus coverage, I believe it is, to some of those build flags. And just using a coverage file here is what Zeno suggested. And it's a nice little trick, because in any project that I want to apply code coverage, the command is basically this, and I don't need to modify my existing cmake files. I did that without these lines here. And then I spent a few hours trying to figure out why did nothing work for me. And in the end, it turns out that, at least from our internal documentation, somebody wrote that they had problem getting it working with clang, which is exactly what I was using as default. So instead of using clang as my compiler, I set up that my compiler for the C++ should be G++ here, and for the C it should be GCC. So let's kick that off. That will start the build step for this, or running the cmake step, as you can see now. And now it's done, and then it's time to build the project. And if you can see, there's 1164 steps. So let's just switch over and look at the configuration file while it's building. So what the coverage.cmake file really does is just add, as you can see, append here to a number of the flags. So C flags and CXX flags and linger flags and whatever flags here. And what it does is just add this minus coverage to all of them. There is an alternative where you can specify more specifically what it should be doing, like what should it be linking against. But there's no reason to do that. Minus coverage, cover you. No pun intended. Anyway, so once I have built it like I've done now, I will have my code instrumented, so it will generate tracing for what is being called how many times. And from that, tools will be able to give me a report that shows the code coverage. And we'll get to that in a second. But in a perfect world, what I would do now is to start my unit test. Unfortunately, I don't have a unit test that covers the whole application. So instead, I could also just start my application and just try and go through all of the application. That was at least my intention, which would take me hours and hours. But at least after that, I would have a good idea of where I should pay more attention to if there is dev code. So let me start the application. It goes like this here. My beautiful designed login box, and it will start up the launcher over here, and I can go with my quick launcher. It's a beautiful red rectangle, isn't it? I am really just designing this application for people in Qt, so I care less about what it looks like, which a lot of people is complaining about. Anyway, let's go and look at the exchange rate. We've got them here. So that's the exchange rate for quite a bit of time. So what I really just wanted was to start the application so we could see something happening in here. So I'll quit the application again and say, thank you for this time. So now I've instrumented my code, I've executed the code, and it generated a bunch of files on my file system with information in. And it's time for me to produce the report. And for that, there's at least two different options. There is a tool called gcov, which I tried, and it just continued telling me that the gcov binary and the instrumentation from the compiler was with different versions. At least that's how I interpreted the error messages. So my bad for not figuring that out. And then there's the other tool called gcovr, which is what I tried then. And what you see here is gcovr. As you can see from the prompt over here, it took a bit over a minute to run this gcovr. So that's why I did it up front. But what it basically tells is --root, this is the source directory, -j10 to use more cores, --HTML details, which we'll see in just a second. But it will generate me, for each and every of my source file, it'll generate me stuff, or generate me the source file with indication of what has been tested and what hasn't, or what has been executed and what hasn't. And then finally -o HTML /. I learned that the hard way. If you do not add the /, then it will simply generate you a bunch of files in the current directory rather than in the subdirectory that I intended for. And then finally dot, indicating where should you go and look for those files that has changed. And before we go and look further, let me just run this small command here. You can see what it generated was a bunch of gcda and a bunch of they were too long ago. Then gcda and gcno, and one of them was during the execution, and the other, I cannot look it up. It will tell you the details. Anyway, for open HTML, that's just an alias I have, and then in here coverage detail.html, and that will bring up the coverage of my application. You can see I am pretty good covered here. There's a bunch of header files that from time to time comes up, and this is, well, it's not even my code. Well, Qt algorithms up there was Qt algorithms, but there's a bunch here that actually does pretty well, and that's just one line in here. So, okay, let's go back and search for exchange rate. That's the application that, or the dashlet that I brought up here. And what you can see in here is that the exchange rate, some of the code has been covered and some of the code hasn't. And I know my code pretty well, so I know this is when I click in a cell to edit it, that will bring up this delegate will be executed and bring up an editor. So we can try that in a second to see it getting covered. I can also see a bunch of peculiarities in this. So if I click over here and open it up, it will tell me that branch 1 was taken 1672 times and branch 2 was never taken. And then I look at this line, qvar and value equal to index.data. And there is a link right here where you can go and read up on what the branch stuff is all about. the way they explain it is that you need to look at the assembler code and look at the jumps in the assembler code. And on the assembler level, there's actually two different branches from that one line. And one of them is for normal return. The other is if an exception is thrown, I think, but go and look at that URL. So reading a bit of documentation gave me the insight that I actually need to add 2 flags if I don't care about these odd numbers. And as you can see here, the flags are minus exclude unreachable branches and minus exclude throw branches. And when I do that and I start up my viewer again, then you can see here now that it says 1 of 1 is being executed. There's one down here that says 3 of 3, and you might wonder again, what is that? Well, there's one branch for calling that function, one branch for calling that function, and then one branch for the operator equal to. I think that's how it's interpreted. But again, I'm not entirely sure. It also, if we go back to my shell, it took quite a while again. I was sitting here waiting for 1.5 minutes for it to run. And if I really just want to look at the subdirectory in this, then I can run a command that looks like this here. And I'll even let it run while I record, because now it's done already. And you can see the difference is that instead of period up here, I specify the directory where it should look for it. And I specify multiple directories if I want to. And if I look at my report again, now you can see that it doesn't include all my files. It only includes those files in the MISC and files that it's called. I think that's why you'll see those. So yes, these are only header files that was called from the MISC directory. That's also a minus filter option. So if I really want only to see the MISC and not any of those, then I could make those go away using the minus filter. So one thing that is worthwhile understanding of how gcov works is that it's accumulative, meaning that when you run multiple tests or multiple times your application, then it will just add to the recording, which is a feature, it's not a bug, and it's especially useful when you run unit tests. So what you see here is I have a test case here, bin test range. It's executed pretty fast, and I can now do a command similar to what we've seen so many times before, but I look into the core directory because that's where my test cases are for that part, and I can bring up my test case, and I can see that core quarter has not been executed at all. You can see that I looked at it in preparation for this one, and my core date range, which was what I just tested, that one has now some coverage in it. If I quit my application here and I now run, instead of the test for date range, I could run the test for quarter, and I run my export again. That was a bit too fast. I need to run gcov first and then look at the output. What you'll notice is that now my quarter down here has, okay, admittedly not very much code executed, but still my date range up here still has the execution. So it's accumulative. So if it's accumulative, what happens if I change the actual source file? Well, let's try and do that. So if I'm now looking at the code coverage report for quarter, and you can see that there is quite a bit of untested code in here. And if I look at the very first here, quarter from date isn't tested, I can definitely easily test that one. So that's over here. Let me just type real fast, quarter from date, so on. So I'll save that one. I'll go over here in my code. And of course I need to remember to compile the code now. And I will run the unit test for quarter again. That's what we have here. And it worked just fine. Though there is an error here now. It says, hey, careful now. You are actually running or updating this file here. And the source file has actually changed this checksum. So it notices that I have a file change here. I can choose to say, error, whatever, it's fine with me because I know that I changed that file. And let's just go in and look at what the code looks like here now. I need to run gcov again. like that. And I need to look into the HTML report again, and it was quarter. And we can see that the code from date now has been tested. Well, not all of it, but at least more of it. And the other part up here is also green, but that's because that it actually did test those lines in the new test run. So what it did when it saw that this file was overwritten was that it threw away the old one and started completely from new. Feature bug, should it have been failing on me entirely? That's up to you to decide, but it's how it is. Now, I'm a Qt Creator user, so I would like as much of this to be totally transparent from within Qt Creator. So I looked at what are my options, and thank you goes to Paul Lemire, who replied to Zeno's original email with his suggestion for what he's doing in a project. And what it basically looks like is this here. So first of all, I have this option KDV for QTopia code coverage. It tells me the text here code coverage, and it's off by default. And what it gives me is that inside here I can see KDV code coverage is a checkbox, and it's, well, I've checked it on now just to show this code here in action. And what I then do get from that option up here is that I can do a test like this. If code coverage, then do these lines of code. And what those lines of code does is that first of all, I include this cmake file that Paul Lemire found on the internet, and there's a link to it right here now, so you can go download it yourself. I put that into a cmake subdirectory, well, that's where I find it. And then in that cmake file, there is this append coverage compiler flags, which will add this minus coverage to my compiler flags in the right places for me. Next, it has a setup target for coverage gcov HTML, which is basically the running gcovr using all the right options. And what I get out of this is a target in my cmake file called KDV coverage. So I rushed over here. I looked through my list, and unfortunately it didn't show up. And that's where David helped me quite a bit looking into this. And eventually I talked to somebody from the Qt company, and I filed a bug report, because that is unfortunately not possible to get it in here. It's only those targets that are executables and marked like this that shows up there. But what I can do is that I can use the Control-Shift-K down here, and then cmake. No, come on. Cmake. Yes, that's good enough. Okay, there it is. Cmake, and then KDV underscore coverage, and now it's running. And while it's running, it'll take a bit of time. Let's just see what it does here. It basically run my C test, and as part of running the C test, it will also run the gcovr generation of HTML. And let's go over and look at what that final report looks like. First of all, I need to realize that the report is generated in the build directory. And given that I have an out of source build, I needed to find the build directory, which of course is different from the one that I had before. But as you can see, I found the build directory here, and I look at this file called index.html in this directory name, which came from the cmake file. So I look in here, and what I'll find is my report here. And you can see pretty good coverage here, 46% of the lines covered. And of course I cheated like no tomorrow, because between running that step, I also ran the auto self-test in QTopia. But I now have the confidence that at least when I do a release and I just run the self-test, which basically loads in all the dashlets, 107 of those, and compare what they look like to a baseline. And if all of those passes through, then I know at least that I've seen 46.9% of my application. It's not 100%. There are enormous amount of bugs that could potentially be in the remaining percentage. And even if I got to 100%, I could still have bugs in there, because what it just tells me, if it says 100%, it tells me that I've been through 100% of the lines in my application. But it could be that if I go through line A and then B, that there is no bug, and if I go through line A and then line C, that there, well, line C and then line B, that there is a bug. So even though B has been tested from A to B and not from C to B, it might be 100%, but not give me all the bugs. And I'll leave it for another time to discuss whether you even want to go to 100%. You don't, because the value in the remaining percent, as you saw in there in the code previous, there was some test for what happens if you give me an invalid date and you ask to convert that into a quarter. And there is a test case for that. But there is no usage in my code for that. It's just being a bit protective when I'm writing that code. And now to the $100,000 question, or whatever the number is these days. Jesper, would you use this for what? Would you actually have that target in your code there? I don't know. I'm not entirely sure how much value this adds to me. For a start, the list here is 100 pages of HTML screens long, which is kind of difficult to get an overview of. In the next version of gcov, which my Linux didn't have and I couldn't get it working when I tried for 10 minutes, it has support for putting it into subdirectories, which will definitely help. And even if I decide to start using this, I would definitely not run it on all the code in there. I would find the core bits where there's most logic that needs to be tested and just apply that. But then again, it might be useful when I'm writing unit tests. As you saw, my quarter was utterly untested. The hard part of it was tested, but you never know. It might be useful, if for no other reason, just to motivate myself to go an extra mile when I write the unit test. And that's it. But I have a short announcement before I leave. I have good news and I have bad news. What do you want to hear first? The bad news? Okay, the bad news is I will not be putting out as many Qt Widgets and more episodes in the coming months as I've done in the past. The good news? Okay, the good news is that we decided that we will put our programming with Qt Widgets training up on YouTube, just as we did with the QML training. And that should give you, I don't know, close to 100 episodes coming up over the next year. I promise you there will be Qt Widgets and more episodes too, because I will for sure find stuff that, just like what we've seen today, that I've decided, hey, that is worthwhile an episode. But I will be spending quite a bit of time recording that series, and in that time I will likely not tread as much new land as I do when I just do my regular work. Anyway, I hope to see you in that series too, and otherwise stay tuned. There will be more in Qt Widgets and more. That's it for this episode of Qt Widgets and more. I hope that you got something out of it, at least. I was a bit surprised how difficult it was to get code coverage working from within Qt Creator, and I hope that they will take my bug report and they might even consider improving Qt Creator so that code coverage from within there is almost as nice and easy as this is with many other things inside Qt Creator. Until next time, have a great time.